So this is 4-4, solving imperfect roots. Today, we'll be just solving roots that can't be simplified to an integer. So, for example, if we had the square root of 50, right, that can't be simplified directly to an integer because the square root of 50 is approximately 7.071, right? So, how do we simplify this? So as we learned in multiplying roots 4-2, we know that when two roots are multiplied, you multiply the inside and then you put them all under the base, right? So we know that the square root of 50 is equal to the square root of 25 times the square root of 2, right? But wait, the square root of 25, that's equal to 5, right? So the square root of 50 is just 5 times the square root of 2. Just pull that down, multiply. It's kind of redundant, and the square root of 25 is just 5, right? So this is the answer. And since, oh, by the way, there's no like positive or negative sign, so you just assume that it's positive. So that's your answer. That's how you simplify it. That's it. Um, so all you really need to do is just look inside the number, and if you see that it can be divided into that that is a perfect root, then just do this is through prime factorization. So just factoring, for example, if we looked at 50, the square root of 50, if we prime factored it, 50 can be separated into 25 and 2. Right, 2 is a prime number, so we can just simplify the 25. 5 and 5. Right, the prime factorization of 50 is 5, 5, and 2. Okay. If we had, right, 5 is already a prime number, separate 10 into 2 and 5, and we still get the same, right? So since this is a square root, and we realize that there's 2 5s, we can take that out. So now we get square root of 5 times the square root of 2. Square root of any number times the square root of that same number is equal to just that number. So we get 5 times. So apply that to a different root. 2, 2, just do 75. What is this equal to? You answered 5 times the square root of 3, you'd be correct. This is equal to the square root of 25 times the square root of 3. The square root of 25 is just positive 5, and then 3 up there, and you get 5 times the square root of 3. Right, so that's really all you need to do for today. This is basically it for roots. Let's do like a harder one. What is the square root of 224? This may require you to do some prime factorization if you can't immediately see the square, the perfect square inside. The answer to this is 4 times the square root of 14. From 224, we obviously see that can be divisible by 2. right? So you get 1, 1, 2. 1, 1, 2 can still be divided by 2, and then you get 6. You can still divide 56 by 2. You get 20. It can be divided by into 2 and 14. 14 can be divided into 2 and 7. So we have 2. We have a set of 2 here, a set of 2 here, and just 7 and 2. Right? So 2, the square root of 2 times the square root of 2 is positive 2. The square root of 2 times the square root of 2 is just positive 2. Like, just square root. Anyway, 2 times 2 is 4. So we have 4 here. 7 times 2 is 14. And since they aren't part of a pair, then their answer should be 4 times the square root of 14. Alright, so now let's do a pretty hard one. What is the square root of 323? The video. This may take a bit more time. The answer is the square root of 323. You'd be correct. This cannot be simplified even further. If we took 323 and did prime factorization, we'd find that the prime factors are 17 and 19. That's it. Since 17 and 19 are different and they're not they're not like square roots or anything, you can't do anything about it. 323 is equal to 17 times 19, and the square root of 17 and the square root of 19 are still irrational. So you cannot simplify this number even further. And I will randomly throw in some numbers that cannot be factored, and most of them, keep that in mind when doing something. That's it for today. There's going to be homework test on Friday. Due on Friday, and yeah, I hope to see you tomorrow for the test, and then next week when we if hold up, I look search it up on algebra.webador.com. It's in the unit section. So the next week will be polynomials, so identifying terms, adding and subtracting polynomials, multiplying binomials and polynomials, and then special trinomials. We'll learn all about them next week. We're not going to do factoring, which we were going to, but we're not anymore. We're going to do quadratic equations and then systems end off. So yeah, that's it for today. Hope to see you tomorrow for the test, and yeah.